probably thinking about earthquakes along the San Andreas Fault.
There is an 800-mile-long crack in California that runs from the Salton Sea in the south to Cape Mendocino in the north, crossing vineyard subway stations, power lines, and water mains. Millions of people live and work alongside the crack, with many passing it on a daily basis via the 966 roads that cross it. The majority of people don't give it much thought, but in reality, that crack, which is the San Andreas Fault line, has the potential to destroy lives and bring the national economy to its knees in the blink of an eye. Most people are familiar with the San Andreas Fault, a monster that divides California from south to north as two tectonic plates grind against each other, threatening large earthquakes. It has already happened in the past, and residents have been warned yet again that another disaster is on the way. In fact, the earthquake occurs every 22 years, with the most recent one occurring in 2004. If history is any guide, another one may be closer than any Californian would like. The director of the Southern California Earthquake Center, Thomas Jordan, recently delivered a warning that should have sent chills down the spines of all Californians. The San Andreas Fault appears to be in a critical state, and a huge earthquake appears to be impending. This isn't the first time Californians have been warned about a potential threat. However, the southern portion of the fault looks like it's locked, loaded, and ready to go, according to the warning. So why is this renowned seismologist making such grim forecasts? In reality, there hasn't been a large release of stresses in the San Andreas Fault system's southern part since 1857. The San Andreas Fault system is one of several that generally mark the boundary between the Pacific and North American tectonic plates. Both plates are advancing northward, but the Pacific plate is moving faster than the North American plate, indicating that forces between the plates are growing all the time. Some of these stresses were tragically released in the San Francisco Bay Area in 1906 in the form of a 7.8 magnitude earthquake, and again in Northern California in 1989 in the form of a 6.9 magnitude earthquake in Loma Prieta. Fortunately, no disasters of this scale have happened since then along the San Andreas Fault in the state's south, although the 1994 Northridge event was linked to a nearby but distinct fault system. However, the lack of a quake raised the likelihood that one is on its way, and that given the amount of stress that has accumulated, it will be the big one when it hits. So how big could this prospective earthquake be, and could the catastrophe shown in the film San Andreas possibly happen? In short, the answers to these questions will to some extent satisfy Californians. The San Andreas Fault generates a 9.0 magnitude earthquake in the film. While not unheard of on a worldwide scale, earthquakes of this size are normally confined to places of the Earth where one tectonic plate is moving beneath another, such as Chile and Japan. The tectonic situation in California is unique in that two plates are slipping past each other. As a result, many forecasts place the maximum earthquake magnitude along the San Andreas Fault system at 8.0, with a 7% chance that such an event may occur in Southern California over the next 30 years. There is also a 75% likelihood that a magnitude 7 event will occur during the same time frame. While magnitudes of 7.0, 8.0, and 9.0 may appear minor, the energy generated by such events varies greatly. A magnitude 9.0 event will produce 32 times the energy of a magnitude 8.0 event and 1,000 times the energy of a magnitude 7.0 event. Destruction is inescapable, whether a 7.0 or an 8.0, but the entire sequence of events described in Dwayne Johnson's movie is unlikely. Because the San Andreas Fault is not beneath the sea, any slide along it, for example, could not displace enough water to generate a tsunami. The creation of a large gap is likewise a fantasy, as the plates are sliding relative to one another rather than away from each other. What is likely is that there will be significant destruction. While California's building standards are rigorous, suggesting seismic protective measures for older buildings and barring the construction of new buildings along known fault lines, there is no way to totally secure a building from a natural disaster. To fully comprehend the consequences of such an event, a thorough study of the fault zone is required. So how many fault zones are there? They are divided into 3 sections: northern, southern, and central. The northern part of the fault goes from Hollister through the Santa Cruz Mountains, which was the epicenter of the 1989 Loma Prieta earthquake, through the San Francisco Peninsula, where it was first observed by Professor Lawson in 1895, and eventually offshore near Muscle Rock in Daly City. This is the approximate position of the epicenter of the 1906 San Francisco earthquake. In Marin County, just north of Stinson Beach, the fault resurfaces a Balinese lagoon. The fault then returns underwater through Tamales Bay's linear trough that separates the Point Reyes Peninsula from the mainland, travels just east of Bodega Head, across Bodega Bay, and eventually returns onshore at Fort Ross. Furthermore, there are numerous important sister faults that run more or less parallel in this region around the San Francisco Bay Area, each of which can cause significant catastrophic earthquakes. The northern leg extends over land from Fort Ross, forming a linear valley through which the Gualala River flows in part before returning to the sea and Point Arena. It then runs underwater along the coast until it reaches Cape Mendocino, where it begins to turn west and finishes at the Mendocino Triple Junction. Then there's the central portion of the San Andreas Fault, which runs northwest from Parkfield to Hollister. While earthquakes occur in the southern region of the fault and in parts of Parkfield, the majority of the central section of the fault exhibits aseismic creep, a condition caused by a transform boundary in which the fault slips continually without generating earthquakes. Finally, the southern segment, often known as the Mojave segment, begins at Bombay Beach in California. Upturned strata connected with that portion. The fault can be found near the Salton Sea in Box Canyon. The fault then travels northwest along the northern base of the San Gabriel Mountains through Cajon Pass, and finally along the southern base of the San Bernardino Mountains. The transverse range of mountains is the result of movement along the San Andreas Fault. A piece of the fault can be seen in Palmdale at an Antelope Valley motorway road cut. The fault follows Elizabeth Lake Road northwest until it reaches the community of Elizabeth Lake. As it passes the communities of Gorman-Tejon Pass and Frazier Park, the fault begins to bend northward, forming the Big Bend. This restraining bend is assumed to be where the fault locks up in Southern California, with an earthquake recurrence interval of 140 to 160 years. The fault then extends northwest of Frazier Park over the Carrizo Plain, a broad, treeless flat with much of the fault exposed. Within the plain, the Elkhorn Scarp runs the length of the fault path. A new study of rocks drilled nearly 2 miles beneath the surface reveals that the central section has been the location of multiple significant earthquakes, some of which may have been quite recent. The study, which uses new chemical analysis methods to assess rock heating during prehistoric earthquakes, was just published online in the journal Geology. This suggested that stronger earthquakes may occur in the central section than previously assumed, according to lead author Genevieve Coffey, a doctoral student at Columbia University's Lamont Doherty Earth Observatory. Everyone should be aware of the possibility that it's not always just continuous creep. The San Andreas Fault poses numerous dangers. The northern section was the scene of the deadly 1906 San Francisco earthquake, which killed 3,000 people and devastated much of the city, while the 1989 magnitude 6.9 Loma Prieta earthquake killed over 60 people and destroyed a major elevated highway. The southern section was responsible for the 1994 magnitude 6.7 Northridge earthquake near Los Angeles, which killed approximately 60 people, and many scientists believed it is storing energy for an event on the scale of the 1906 earthquake. The central section, on the other hand, appeared to be calm. Only one small location towards its southern end has been linked to actual earthquakes. Every 20 years or so, there are magnitude 6 events that are not extremely threatening by most measures. Because of their frequency, scientists intending to analyze indications that may indicate an imminent earthquake have erected a large observatory atop the fault near the city of Parkfield. It consists of a 3.2 kilometer deep borehole from which rock cores were extracted, as well as monitoring equipment both above and below ground. Now, it's widely known that an 8.1 magnitude earthquake could strike the southern segment, which stretches from Parkfield and Monterey County all the way to the Salton Sea. A big earthquake in this southern stretch would kill thousands of people and cost hundreds of billions of dollars in damage in Los Angeles, San Bernardino, Riverside, and surrounding regions. However, even after locating the fault, scientists needed to perform more research to better understand the repercussions of a massive southern San Andreas earthquake. To depict the stresses that have accumulated in the area since the last significant event, popularly known as the shakeout scenario, the US Geological Survey generated a 7.8 magnitude event with a slippage of 2 to 7 meters. According to this model, the structures crossing the fault would receive the most damage. Fortunately, since the Alquist-Priolo Earthquake Fault Zoning Act of 1972, such structures have become uncommon. However, the 966 roads, 90 fibre optic cables, 39 gas pipes and 141 power lines that intersect the fault zone would be affected. The entire cost of building damage was projected to be in the tens of billions of dollars, probably around $35 billion, with contemporary buildings faring well, but older buildings being particularly vulnerable. As gas mains and main water pipes were severed during the disaster, fires would blaze as they did after the Northridge earthquake. In fact, the damage caused by the resulting fires is considered to be greater than that caused by the original earthquake. The death toll has been estimated at 1,800, and just when you think things can't get much worse, the major event will destabilize the region's tectonics, triggering a series of potentially deadly aftershocks. For example, in 2011, a 6.2 magnitude earthquake struck Christchurch, New Zealand, and the city and surrounding region have since endured over 10,000 aftershocks. Fortunately, the film San Andreas is pure fiction, with the dramatization we've come to anticipate from filmmakers who, ironically, are based in Southern California. Nonetheless, the San Andreas Fault will almost certainly produce a significant earthquake in the not-too-distant future. And when it does, the devastation will be substantial, affecting Southern California severely. Californians, on the other hand, are no strangers to such catastrophes, and the state's infrastructure was recently developed with earthquake protection in mind. Let us know what you think of the San Andreas fault line in the comments section below.